All right, so for today's task, we are uh, going to be determining the x-intercepts given graphs and also given equations. So the first part here is we'll try to understand what x-intercepts are. Sometimes x-intercepts, they should have an S here if we have multiple x-intercepts. Sometimes the questions will be what are the zeros or roots, sometimes even the word solutions, so they are interchangeably used. It just depends on whether they want it to be presented as a point or just a value of the x coordinate. Okay. So what are x-intercepts or zeros and roots? Okay. So we have six graphs in here. So if you're given a graph, it's easy. It's very easy to find where the x-intercepts are. So if you have an xy axis, okay, that's really straight, and you have some random graphs like this. So the x-intercepts is where your graph, this orange one, crosses the x-axis. So these are your x-intercepts. So whatever the value of x there, that's your x-intercepts, okay? So let's look at graph A. So how many times did your U-shaped graph, a parabola, crosses the x-axis right here? Well, it crosses it twice, right? So just for this graph right here, you have your x-intercepts are -2 and +2. Now, sometimes these are given as x values, but sometimes they may want to write it as -2 comma 0. So meaning that point right there, the coordinates are negative point comma -2 comma 0. So they could be asking you for the actual point coordinates or just the value of x, depending on the question. Okay. And also for this one, that will be 2 comma 0. So you can see the x-intercepts, because they are on the x-axis, the y coordinate will always be equal to 0. Okay, so let's move on to the second graph. The second graph is a linear equation, it's a straight line. So therefore, it only crosses the x-axis one time. So what is that point? Well, you can say x equals 4. That could be an answer, or you could also say 4 comma 0, depending again on whatever is the question. Okay, so but the important thing is that the x coordinate is equal to 4 and the y coordinate is always going to be equal to 0 for x-intercepts. So, okay, so this is a quadratic function, meaning this is the highest exponent of this one is going to be some kind of x squared. So, meaning 2 is the highest exponent. Linear highest exponent is 1. Well, this one here, how many times did it cross the x-axis? Well, you have it 3 times. So, this is an x cube thing. This is a cubic equation, meaning the highest exponent is 3. And as you can see, you have 3x x coordinates or x-intercepts for this graph, okay? Now for letter D, this is a quartic. This is a x to the power of 4 equation. This is your x-axis. That's your graph, the blue one, crosses the x-axis. Nope, not really. So this one here, no x-intercepts here, okay? No, because it does not really intersect the x-axis. Now, how about this one? This is a sine graph. This is x-axis. This is y-axis. How many times? Well, it goes, actually, this is periodic. So there, it comes every so often. So you have all of those. Those are all your x-intercepts. Now, this one right here is also another quartic. It crosses the x-axis 4 times. So in this case, you have 4x intercepts. Okay, so that's how to recognize or determine the x-intercepts, zeros or roots based on a graph. So right now we will try to learn how to do the same thing using just plain equations. Okay, so let's get that material. So I'm gonna come up with some random equations. Okay, so and from now on, so we will be finding the x-intercepts given an equation. Okay, so let's start with the first one. Let's say you have y equals, let's see, what y equals, let's start with something easy. X squared y equals x squared plus minus maybe minus 1. Okay, so to find the x-intercept given an equation, look at your highest exponent. Your highest exponent is 2, so that means you're probably expecting two answers there, assuming you have real numbers. And since this equation is equal, I mean this expression has a highest exponent or the degree of 2 or greater than 1, we will have to set that equal to 0. So you can say x squared minus 1 is equal to 0. Okay, and so now we can factor this side, okay, equals 0. We can factor this as x plus 1 and x minus 1, right? And so therefore you have two values here, x plus 1 equals 0, x minus 1 equals 0. And then you solve for each one. The first one is x equals negative 1, and then x equals, you add 1 on both sides on the second part, x equals positive 1. So that means you have two potential, actually two x-intercepts for this equation right here, okay? So that's example number 1. Again, the degree here is 2. Now let's try, okay? I'm going to erase this. I'm going to have another set of questions. Okay, so let's try this one right here. So you have x to the fourth, or actually we want to do it as, okay, so you have f of x equals x to the fourth minus 9x squared. So the idea here, the highest exponent or the degree is 4. So if if the degree is not equal to 1, you want to set it to 0 so that you can factor that expression, okay? So what I'm going to do is I'm going to do x to the fourth minus 9x squared equals 0. Now, why do we equate it to 0? Remember when we have a graph earlier and you have that, say for instance, x-intercepts here? Remember we have these x values and the y coordinate of that is always going to be 0. So that's why we can effectively say that x is equal to, that the whole equation is equal to 0. Remember this side right here is y, right? So we're saying when y is 0, what is the value of that x? That's why we can equate it to 0. Okay, so now we have that equation. We can factor it. Okay, we can factor it using greatest common factor. You have x squared. Okay, so you have x squared here minus 9 equals 0. So you factored out x squared. You divide the first term by x squared. You have x squared left. Negative 9x squared divided by x squared. You have negative 9. Okay, so now we can factor the one in parentheses. This one cannot be factored as it is, as simple as it is. The one inside is a difference of two squares. These are two perfect squares and you have a minus sign in between them. So therefore the square root of the first term is x, the square root of the second term is 3, one is plus, one is minus, equals 0. Now remember you have the highest exponent of 4, right? So that means you're expecting potentially 4 or 2, or I mean 4 or 6 or 8 potential answers. So therefore we can actually factor each one here. So you can say x squared equals 0. So therefore your x here is equal to 0. It has a multiplicity of 2. So meaning there are two factors of 0 because of that exponent there too. Now each one here you have x plus 3 equals 0 and x minus 3 equals 0. Subtract 3 minus 3 on the second factor, so x equals negative 3. All right, so that's 1. And then plus 3 here, plus 3, therefore x equals positive 3. So these are your x-intercept 0, negative 3, and 3 for that problem. Okay, now let's do a second example. Let's have x cubed, or we should say f of x. Okay, so f of x equals x cubed minus 7x squared plus 10x. Okay, so again, we can set this one equal to 0. So we can say x cubed minus 7x squared plus 10x is equal to 0. You have three terms here, and you have a common factor of x. Every single one of them is x. So therefore, you can factor that x, right? So x cubed divided by x, you have x squared, you subtract the exponent, minus 7x, x squared divided by x, subtract the exponent, plus 10 equals 0. Now, the one in parentheses can be factored out, right? So it's like the one inside of parentheses, your C is 10 and your B is negative 7. So therefore, we're looking for two numbers that when you multiply will give you a 10, but when you add will give you a negative 7. So what are those two numbers? Well, that's going to be just negative 5 and negative 2. Negative 5 times negative 2, you have a 10. Negative 5 plus negative 2, you have a 7. So those are the two factors. You bring down this x, and then this big parenthesis right here will be factored out into 2. And what are those? We will have x minus 5 from here, minus 5, and x minus 2. So those are your factors. Now that you have the factors, each one that has some sort of x, you can equate to 0. So you can say x equals 0 for the first factor, then x minus 5 equals 0 for the second factor, and then you can say x minus 2 equals 0. So for each one, this is already solved. Plus 5 here. So therefore your x equals 5. That's the second one. And then plus 2. Therefore your x equals 2. That is the third one. So this, for the second example, this one right here, you have three x-intercepts. Okay, so I hope this helps. If you have any questions, let me know, and I'll see you next time.